Hello everyone. I am Nitya, working as an assistant professor in EC department, R.M.K College of Engineering and Technology, and I'm handling control engineering. Today we are going to see fifth unit. Your fifth unit is state variable and state space modeling. In this we are going to see concept of controllability and observability. First we will concentrate on controllability. We will see what is controllability. Actually, the controllability verifies the usefulness of a state variable. In the controllability test, we can find whether the state variable can be controlled to achieve the desired output. The choice of the state variable is arbitrary while forming the state model. After determining the each state model, the controllability of the system variable is verified. If in case the state variable is not controllable, then we have to go for the another choice of the state variable. Actually, this is the definition of the controllability. A system is said to be completely controllable if it is possible to transfer the system state from initial state, that is x of t naught, to any other desired state x of td in a specific finite time by the control vector u of t. That is, when we have a system actually that we need to transfer some of the data. While we are transferring the data, we are considering it as an initial state. While we are transferring, we should get the data at the desired state with a finite time. So then we can call that system as a control system. So we can call it as a system is under controllable. Now we will see what is observability. In observability test, we can find whether the state variable is observable or measurable. The concept of observability is useful in solving the problem of reconstructing unmeasurable state variable from measurable one in a minimum possible length of time. In state feedback control, the estimation of the uncontrollable state variable is essential in order to construct the control signals. So this is the actual definition of the observability. A system is said to be observable if every state x of t can be completely identified by measurement of output y of t over finite interval of time. That is, while we are giving some input to the system and we are getting that output, in between we can able to read or measure the system, so that we can call it as an observability, so that we can call the system as a system is completely observable. So this should happen in a finite interval of time. Here we have two types of method to say whether the system is controllable and observable. The two methods, first method is Gilbert's method and another one is Kalman's method. Okay, now if we see for a Kalman's method, the calculation is very simple when compared to the Gilbert's method. Whereas in Kalman's method, the major disadvantages is that we can't able to predict in case if we are getting the system is uncontrollable or unobservable. We can't using a Kalman's method, we can't able to predict where the system, that is where the state variable is uncontrollable or unobservable. Whereas in Gilbert's method, we can say where the system is going to be uncontrollable. That is, we can able to predict the state variable where it went for uncontrollability or unobservability. So this is the major advantage and disadvantages of these two methods. So we will see, we will use these methods to solve the problem to predict the system whether it is uncontrollable or uncontrollable, observable or unobservable. This is the problem statement, that is, consider the system with a state equation. They have given you the variables and then the requirement is estimate the state controllability by using the Kalman's test. They have asked us to find using the Kalman's test. Though, in order to find using Kalman's test, first step is to find the matrix. We need to form a matrix. For that, the formula is B, A dot B, A square B, and it goes on A n minus 1 B. Actually, this is the step 1. First, we need to form the QC matrix. C is nothing but your
controllability. C represents controllability. For that, we need to first form QC by using this formula. And then step 2 is we need to find determinant for QC. Once we form the matrix, we need to find the determinant of QC, and this QC, that is the determinant of QC, should not be z equal to 0, and it should be a non-zero value. Then only we can call the system as controllable system. If it is 0, we can say it as an uncontrollable system. So before proceeding this, we will check with the problem, and we need to remember the one important thing, that is your state model equation. That is x dot. This represents the first order derivative is equal to ax plus bu. And whereas for your output is cx plus du. Now, for finding your controllability, we need to consider this equation. Compare this equation along with your question to find your A value and B value. Okay. Now, compare this equation with this. So, this could be your x dot. That is your x dot is nothing but first order derivative. And comparing this, this is your A x plus B u. So, now we got what is the value for A and what is the value for B. Now what we need to do is we need to find what is n here. Okay, first we have taken what is A and B. Now our procedure is to find what is n. So n is nothing but the order of the system. It is the order of system, or we can say it as the number of state variables, or we can say it as number of state variables. So if we see for the question, we can see it is x1, x2, x3. So totally we're going to have 3 state variables here. So n will be z equal to 3. On substituting here, that is n minus 1, 3 minus 1 will give you 2. So what we need to do is, first step, qz is equal to, from where to where we need to find the thing. That is b, ab. So we got n as 2. So it is a square b. So we need to find the columns, that is 1, 1, 1, 2 and 1, 3. We need to find up to these 3 things. So after finding this, that is once we get this, we need to substitute what is b, and then we need to find what is a dot b, and then we need to find a square b. For this, first we need to find a dot a, and then we need to multiply that with b. Okay, after finding this, we need to, first step is this. So second step, we need to find the determinant of QC to find whether the system is controllable or not. So this is the procedure to find the system is controllable or not using Kalman's test. Now we will proceed with the problem. Now we will see the solution for the given problem. Actually, we have find out where we need to start and stop. So we need to find up to a square b. So we have taken what is a, what is b from the given question. So this is your a and this is your b. So first thing is we need to find a dot b. So for that we need to substitute a here and b here. So we all know how to do the matrix multiplication. So this first row along with the first column will be solved and put here, and this second row and this first column will be taken place here. Like this we need to complete a dot b. Now the next thing is we need to find a dot b. So for that we can find a dot a first of all, or else we can find a dot b, that is we already got this a dot b. Then we can multiply this with ab. So if we find this, we can get this. So already we have b in the question. We have got a dot b and then a square b also we got. Now we need to form the QC matrix over here. First of all, we need to fill out what is b and what is a dot b and then what is a square b. So we will fill out this. B we got from the question, that is 0, 0, 1. Your a dot b is nothing but this one, 0, 1 minus 6 Your a square b is this one, 1 minus 6 and 25. So we have completed the step 1. Your step 2 is nothing but we need to find the determinant for the given QC. Okay, we got QC. Now we need to find the determinant for the QC. Once we find the determinant, we should get the value as non-zero value. So once we find the QC determinant, we got the answer as 1. It is a non-zero value. Okay, so we can say the system is controllable. And before doing this, before concluding this, we need to find the rank of QC. Why we should find means the rank of QC should be is equal to the number of state variables. We know that n is equal to 3. Okay, we already know this n is equal to 3 from the question. That is, we're going to have 3 state variables here. So before getting into this, we need to find the rank of QC. So we got the QC here. So we need to find the rank of QC. That QC rank should be is equal to n value. That is, both should be 3. Okay, then we can call the system as completely controllable. This is the way how to find using Kalman's test. Thank you for watching.